Hello, and welcome to episode 1 of the Markey Microwave podcast. In our first 2 episodes, we discussed the origin story of how Markey transformed from its traditional business model as a hand-built mixer manufacturer into a cutting-edge MMIC technology company. Our hosts, Christopher Markey and Doug Jorgensen, tell this story in 2 parts. Part 1 follows Chris from his early days at Markey Microwave in 2007 to his development of Markey's passive products to his eventual patenting of the Microlithic Mixer in 2013. In the second episode, we explain how and why we eventually decided to pivot into becoming a full-fledged semiconductor MMIC company. Please enjoy.
Chris, what did Markey Microwave look like when you started? Say before you started, say 2006 maybe. How would you describe Markey Microwave?
Yeah, so in 2006, we had something like 30 to 40 people. I never know the exact numbers, but I'll always say that. Let's say 40 people. There were maybe 2 engineers.
2 engineers defined broadly or narrowly?
People
with engineering
4
degrees.
engineers defined broadly, 2 engineers defined specifically in terms of degrees. Yeah. Then we had a small front office staff. So basically, the point is that it was a small company. Mm-hmm. There were something like 30 assemblers. So roughly 75% of the entire company was skilled solder hand assembly.
And at some point, we'll probably talk about like the importance of that number, that 30 to 40 number.
In terms of ratios between, what's a sustainable, employee base.
What's the nature of a company at that point?
Yeah, and this will be something interesting to talk to Jim Morgan next week about. Yeah, because this is something he and I have discussed many times. Yeah. So the company was, a tried and true manufacturing company. In fact, whenever my mom, I remember this, when I was in college, and whenever my mom would tell somebody about Markey Microwave, and they'd say, "Oh, what kind of company do you guys have?" And she'd say, "A manufacturing business." And I always look at her like, "It's a tech company," and she'd look at me like, "No, it's definitely not a tech company."
Yeah, a tech company makes flying cars and software.
Right. and I think she was definitely right. It was a manufacturing outfit designed around the idea of producing my dad's work.
Yeah.
Okay.
So what proportion of people were in direct production, like meeting customer needs?
99%.
Manufacturing company.
Like there was almost no sales.
Yeah.
And Jessica, I love you. You're probably going to hear this one day, but she was doing, I would say, more inside sales than anything, and then writing my dad's emails. Yeah. Since my dad didn't email. Yeah. And she's probably laughing about that right now.
Okay. So and what types of products did Markey specialize in at that time?
90% of sales came from hybrid mixers. Then
what is a give like a brief definition of a hybrid mixer?
Oh yeah, man, we have to start from
zero. Yeah, no. Okay. Terms of art.
Hybrid mixers for the people who, especially the engineers who come into this field and think that RF is all about RFICs and silicon germanium. It is not. This is the original, call it art, or the original componentry that developed throughout the Cold War was solder assembled product. So hybrid mixers are specifically hand-built mixers, almost always based on a solder assembled part, although that's not universally true. And the circuitry would be fabricated separately from the devices. So the semiconductor devices you use to actuate mixing would be diodes or FETs or something like that, and they would be packaged in a completely separate package and
not integrated.
So not integrated. I guess that's the shorter way of saying all this, right? Yeah. Okay, so hybrid mixers are discrete parts put together, like you would get, a burrito at Chipotle.
Yeah, okay. by a solder assembler.
Yes. So I walked into a company that did that in 2007.
Okay, and how would you describe Markey Microwave 2019?
We've desperately tried to cut back as much of that as possible.
Yeah.
And, I think a theme that we're going to talk about a lot, which is like the impossibility of killing technology. There are technical reasons and logistical reasons why. And, you know, just there's this TED talk that hopefully we can like link to at some point, but it's this idea that you can't kill a technology. Anything that was in the Sears Roebuck catalog like 150 years ago is still available today. Yeah. Not in the Sears catalog, but like you can buy almost everything they used to sell then. And so the same thing goes with microwave technology. Product obsolescence is a near impossibility. There are, you know, systems flying today that have flown for 50 years in the U.S. Military, and the cost to change those components out is virtually impossible. So
what does that mean from a business standpoint or for the company?
Well, okay, so it poses a couple challenges. The first thing is, if you don't want to anger every customer, you have to make sure that you don't kill things that are important, and you have to provision some of your factory to continue to do that work.
So I think we skipped over, if we're trying to not do these things,
yeah.
What things is Markey trying to do?
Are you leading me?
I'm
leading
you.
Answer.
I'm leading.
Okay, what's the answer?
I'm framing the. I'm framing the discussion.
Okay.
I'll explicate the discussion instead of framing the discussion.
Yeah. Tell me where we're going.
Where is Marky Microwave going? This is a big part of my job. So in 2007, it was a hybrid mixer company led by Ferenc Markey and Christine Markey, almost exclusively managed directly by them. Making technology that was like 20 years old, 40 years old, say. Between 20 and 40, a generation old.
And it kind of depended on when my dad invented it.
Right.
Yeah.
But technology starting at the beginning of his career up to, the T3 mixer in 2006, it was still being supported and still being actively promoted and produced.
Correct.
And
they were doing okay.
Yeah. I mean, very well. Certainly. Now, that portion of the business is a very small, fraction, not a very small fraction, but a fraction of the business that Marky Microwave does currently. The personnel that are executing, the people that are here has turned over largely. And I think the most important thing for the angle of this discussion is that is this something that in some ways what you've accomplished at Markey is something that conventional wisdom would say is improbable, in the sense that Markey had a very profitable business. We've been trending towards lower priced products, certainly, and you have succeeded the founder, which is something that you're not supposed to do. The success rate is low.
So you're getting down to the fundamental question, which is the innovator's dilemma.
Yeah, and so I think that what's interesting is there's a lot of material out there on how to start a startup, and some of it's relevant and some of it's not. But it always kind of takes for granted that you're going to start with VC funding and an idea, hire a bunch of MIT engineers, scale as fast as you can, buy a bunch of customers, and then go IPO or get bought by Google, right? Yeah. There's 5,000 books, podcasts, blogs, meetups, and TV shows about this now. Yeah. Most business questions are not that. Most business questions that people face are questions like you faced coming into Markey, where there's maybe an existing business and you have to make decisions about what am I going to invest in. And some of these decisions were pretty dangerous. Some of the decisions to discontinue high volume, relatively high volume products.
Okay. So I would frame it this way. There were two problems that I had to deal with when I came in. Well, three. Okay. The fundamental problem is, can I run this company after my dad retires? Okay. That was not clear. I came out with a PhD in photonics, and then I went into microwave, which is like not the same thing.
Esoteric.
Okay. Esoteric. So that was a disadvantage. Although I would say in hindsight was an advantage for reasons we can talk about at some future day. Yeah. Okay. There was the technical problem of what we actually do. I had to understand what we did and why people bought it in the first place. That wasn't clear. Yeah. Then I had the other problem, which I think is more the businessy problem, which is how do you steer 40 people in a new direction and not have them hate you? On the technical side, I would give myself arguably an A+. On the people side, it depends on who you ask. If they're still here, I think they like what I did.
Yeah.
If they're not here, they weren't so happy with what I did.
Yeah.
Okay. So, and that's, I read, what's that book? The Hard Thing About Hard Things by
Ben Horowitz.
Ben Horowitz.
Yeah.
I strongly recommend that book to anybody who was in my type of position because it's the only management book out there where they talk about how you're going to lose sleep at night and like have high blood pressure all the time, because that's really what happens. So I had to make decisions where I was like intentionally getting rid of product where certain jobs were dependent on those products. Mm-hmm. And I had to decide whether or not people should keep doing it or they should be retooled or they were even qualified to keep going. Right. That is by far to this day the hardest thing I've ever really had to deal with. The technical stuff I found easy because it was a natural extension of the PhD process.
But I think maybe we're glazing over the aspects of, in retrospect, or maybe at the time, it seemed obvious to go from hand-built products to MMIC products.
Right. Well, I told you that story, right? Like when I was in San Diego, like on my final day there, I remember writing in my notebook, what I need to do when I start at Markey. And like number one was figure out why we still have a business and we haven't been completely disrupted by the MMIC products.
Yeah.
So I was like keenly aware, like before I started, that Hittite should have, punched my dad in the face and taken his lunch money.
Yeah.
But they didn't somehow.
I mean, they didn't.
Well, he didn't know that they were stealing his lunch. It was more like siphoning off. It was like he had a bad accountant who was like taking money and
skimming the books
in the Caymans, and he was like still getting paid. So he was like, "Oh, this is good." He had no idea that the HMC 773 was like,
explosive.
Like explosive, yeah. So, my primary goal was to decide whether or not what we did was even viable.
So to give a little bit of background for people that might not understand the dilemma, do you want to give them a MMIC history, or should I give them MMIC history?
Go ahead.
I'll give a MMIC history. So MMICs are, unlike hybrid mixers or hybrid microwave products, MMICs are integrated. So just like any other circuit, you print the circuitry and you include the nonlinear devices on them. So if you're making a mixer, maybe you use FETs or maybe you use diodes, and you print the circuitry at the same time that you're printing like the gate or the anode or whatever structures you're using. So you have to fit, everything has to be planar. You can't do any of the 3D geometries that Markey, Ferenc Markey made his name on. And there's a lot of performance disadvantages, which is why I think when we started, we told ourselves that these performance advantages couldn't be overcome, and so there was always going to be a market for hybrid mixers.
Well, we didn't. Like my dad literally said,
explicitly said.
He would tell me that my dad doesn't get enough credit for his marketing skills, but he told me on day one when I asked him, Dad, why don't we do MMICs? This is stupid. You can make these things for like $1 a piece, and you're spending $7 on a diode discreetly before you build it.
Yeah.
And he's like, because you can't make as good of a mixer if you do it that way. And I believed him because he was my dad.
Yeah.
And he was a successful, well-known mixer designer. And we published that. And it's completely not true.
Do you think that, in retrospect, it maybe was true at the time and processes have improved, things have changed?
No. Hittite,
the software's
everything
better.
we do today, Hittite could have done in the 90s. I'm convinced of it.
The software wasn't there in the 90s, I don't think.
What do you mean? HFSS existed.
But I don't think that
the devices were basically good enough.
I don't think the computational... Okay, maybe it's possible. So there's no...
The supercomputers might not have been fast enough. AWS wasn't around then.
I don't think that the computing was fast enough. I don't think that you could have iterated the design quickly enough. And there was no market push for it, right? There was no 40 dB isolation mixer. There was no point in making a 50 dB isolation.
Well, so that's like the whole thing about disruptive technology.
Right. Right. So then we're back to the innovator's dilemma.
Right. It always circles back because, okay, so, you're telling the history of ICs. So,
yeah.
Okay. So my dad's hubris regarding MMICs is a telltale sign that you are being disrupted.
Yeah. So maybe this isn't a counterexample of the innovator's dilemma, but proof in fact of the fact that
we were disrupted.
Yeah. Hittite sold for $2.5 billion.
And they sold with $500 million in cash?
$500 million in cash, yeah.
With an 80% margin?
Yeah, at least 80% gross margin.
And they couldn't grow anymore because they owned the entire market.
Yeah, that was a smart move, man.
Genius. I mean, in ADI, I think, you guys are smart. Good job.
Yeah.
I'm also glad you did that. It opened up the door.
Yeah, I don't know I don't know how much more room there was to grow.
Well, they weren't going to be.
I guess ADI is an established company.
The Jeff Bezos thing. Your margin is your weakness.
Yeah.
And Hittite's margin was their weakness. They couldn't go downstream.
And they were public. Well, I didn't remember at the time, but they only went public in the mid 2000s, 2006, something like that.
Maybe, yeah.
So their books weren't open until then.
Right. They were worried. I'm told that when they went IPO, people were worried that the customers would see the margins and be really angry.
I think that what happened isn't that the customers saw the margins. I think the Chris Markey's of the world saw the margins, and you can see their employees saw the margins, and I think now you see what's happening with all the. I mean, that's the explosion of the companies, right?
Yeah. So Markey was disrupted, and I guess I'll give myself credit. I recognized that we were being disrupted, and my dad convinced me that we weren't. But, to my dad's credit, he kept fighting, and he eventually invented the T3, which was an unassailable product line that cannot be done on MMIC. To this day, it cannot be done fully because you can't integrate ferrite. And although there's a company apparently that is kind of working on that right now that we need to go talk to, but that's beside the point.
That's a blue sky project.
It's not commercial yet.
Yeah, we'll be the last ones to get access to the foundry when they figure that one out.
Yeah, that's right. And then they'll just do integrated inductors for cell phones.
Yeah, they'll do $10 billion in integrated inductors and power management.
Oh yeah. DC converters.
Yeah, DC converters.
Okay, so we were being disrupted, and I came in, and my job was to essentially decide what to do. My dad and I came in with no job dictate really, and it wasn't even clear what I was supposed to do from day to day. So I asked my dad what he would do, and he's like, it was a very wise, open-ended problem. He says, take the cash flow from my mixers and go do something useful with it. And so, in other words, he was like, innovate from within with organically generated funding. And, you talk about VCs, this is a completely different mentality. This is, we were playing with our family's money.
Yeah.
If I wasted it, it meant that my family didn't get it.
Yeah.
And so it made me much more careful in terms of what I did. And so what I did was I said, well, we have 30 some odd solder assemblers that my dad claims are the best in the world. And that, in hindsight, was a completely true statement. We have probably the best solder assemblers in the world without question. And I know this because we've tried to outsource certain things when we've had some explosive growth on certain product lines, and it's pulling teeth to get other people to do it. So, I'll hang my hat on my dad's statement. We have the best solder assemblers in the world, no doubt. And because we had that one asset in the factory, I was like, why don't we do other products? My dad was constantly complaining about his diode supply, and every late job was because we didn't have the right diodes.
Right.
And so I was like, Dad, can we do things that don't require diodes? Yeah, you could do other things, like go do power dividers or something. And I looked into it. I was like, yeah, that's a good idea. Let's do those. And then
but it was a crowded power divider market at the time.
Yeah, but there were so many weaknesses. There were so many weaknesses in what was available. Like, even to this day, if you go and buy a power divider from companies who shall not be named, they don't even show you the curves.
It's true. It's
ridiculous.
Dearth of data on data sheets And I think that IC companies MMIC companies have gotten better. The bar has been set higher by companies like Analog Devices.
Oh yeah,
they
set the like tone for everybody.
Yeah, I mean, I remember coming out of grad school and Analog Devices app support was just, I mean, head and shoulders above everybody else, which is probably what you can do when you're,
right. Well, their margins ain't so bad either.
Yeah. When you're an eight-figure market cap company. But yeah, you look at the competition in the microwave industry, and there are still companies that sell products to tables.
Yeah,
which is astonishing.
Like what's the Viswar from DC to 67 gigahertz, 2.5? What?
Yeah.
Like, is it that bad at 10 gigahertz? Well, no, it's much better there. Well, then why don't you show me the curve, man?
Yeah. Don't want to hold yourself to it, like.
Yeah, just show me the curve. That's all I ask.
Yeah.
And that was like my strategy for 4 years, was so I had two strategies. The first one was do things that our factory could build that used largely the same materials that we were already buying. And then the second thing was search out product categories that were supported by designs where the founders were no longer around.
That's a really interesting strategy.
So it was
they can't respond.
Yeah, like, because my dad would say, oh, you need to, well, I'm not going to say their name, but it's like, go look at these couplers. The guy who founded this company was like a genius, and they're amazing couplers. And I would get calls from our customers saying, do you guys make quad hybrids? And I'd be like, no, you should go talk to this company. And then they respond, I did. They can't do any custom jobs anymore.
Yeah.
And so I remember, like, I got this one call from this one guy at one of our currently largest customers. And I said, Dad, could I do this kind of coupler or this quad hybrid? And he goes, oh, I mean, that's a lot of work. But if you know how to do it, I mean, you should, because if they can't custom design anymore, you're in great shape. That's exactly what I did. I locked myself in my dungeon for 3 months. And by the end of it, I had what I now call our coupler design program. This is my MATLAB, right? MATLAB script, which renders
most
everything.
Lucrative.
Oh, the best use of my time ever.
Well, I think I remember at that time I was still at UCSD, and I remember you asking me to help look up papers from like the 50s, and I'd go I would have to go to the library and request an interlibrary loan from UCLA and dust off this old manuscript.
You can't invent anything in the RF space. This is. I hope we get Professor Rubiz at some point. But so for the listeners, Gabriel Rubiz is one of the top. I mean, he might be the top professor in the world.
No offense to the other top professors.
No, I mean, like, they're all amazing. But
he's
Gabriel,
a really smart guy.
Pound for pound, it's hard to argue. I mean, look, he's top 10 for sure.
Yeah, definitely top 10.
So Gabriel is also a pretty good character, and so he started at UCSD like my third year in. So he transferred from Michigan and went to UCSD, and he would always go to these like optics seminars that were held on Fridays, and he'd stand in back, and so we'd have some visiting professor come in from like University of wherever talking about laser somethings. Yeah. And Gabriel at the very end of the talk would go, yeah, that's a really interesting concept. We've been doing that in RF for 40 years. every time. In other words, and ever since, and he did that like
it's so cute that you're doing this.
It's really cute that the optics guys are doing that, but RF has been doing this for since the Cold War. Yeah. And I always think of that whenever I see patents now. Because it's you can't invent anything in this space. It's impossible.
All prior art.
But anyway, so Gabriel would say this every time, and it always stuck with me because when I went into the RF space, he couldn't have been more right. Yeah. Almost in this, I'm going to get some professor, writing me some hate mail, but I would generalize to say that almost nothing new at IMS next week on the research side will be fundamentally different from what was done before. It'll just be done on a new process. It's like you can get a paper on a power amplifier just by moving it up in frequency and doing it on the next process node.
This is
You're shaking your head. You think I'm going to get some hate mail?
I am trying to think of. So, what is new is applying digital techniques to communications. This is what
they've been doing
that
at low frequency. They're just moving it to higher frequency.
Yeah, they've been doing it at low frequency. Well, I guess they've been doing it in audio.
So the big deal,
audio did it.
What's the big deal right now? can we digitize to 20 gigahertz? Can we get rid of the mixer entirely? Okay, which
That's
we'll
a
talk
big
about
deal,
at some
yeah.
point.
Yeah.
You know, Analog Devices is coming out with all these A to Ds and all
Yeah,
that, right?
they
They're
will do
pushing
that.
me to design higher frequency balance. Okay, so I'm doing that. They will digitize.
Yeah.
But what's the difference between doing that up to 20 and doing it up to 200 megahertz? Spur-free dynamic range. And then ridiculous amounts of complexity.
Yeah. I mean,
And you know, heat.
so I mean, you could go back to if you want to like learn about image reject mixers, you can read the papers from like 1910 or whenever, like Reginald Fessenden like first invented the radio
Is
mixer.
that a real guy?
I have his biography.
There's a guy named Reginald
I bought his biography when I was writing the Balin app note, I think.
Yeah.
And yeah, like these guys, way smarter than we are. Like 100 times smarter.
Did you ever read the Matai Young like filter book? The filter, like the holy Bible of filters.
I stay away from filters.
It's impossible to understand.
It's because it's smart.
They're
yeah.
so smart.
Yeah.
There's so much like, yeah.
Yeah.
They were on a different level. The 1950s engineers.
Yeah.
Okay, so anyway, let's circle back.
Okay, wait. Where were we? So you're designing couplers,
Yeah, so I started out doing couplers and power dividers and
Yeah.
and filters a little bit.
but you recognize this like sort of existential threat to Markey.
Yes. And so my
in
idea was to
mixers.
diversify.
So you were diversifying into other hybrid products.
Yes.
Or
That could not be done in mimic form.
that could not be done in mimic form.
And were often done by other small companies without their founders.
Yeah.
A
And
good example come to mind would be like Narda.
well, we
right.
should. Yeah, so I think that there's some more background on the microwave industry that's pretty interesting at this point, which is that the peace dividend
Yeah.
led to the peace dividend is when Markey was founded.
Yeah.
So
What is the peace dividend? You have to explain.
So the peace dividend is in 89 or 90, the Berlin Wall fell, the Cold War was over. During the Cold War, the cost no object on electronic warfare components, which was very 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 important that we had superiority in terms of electronics.
And radars,
so
yeah.
and radars. So there was heavy investment in this technology, and then the Soviet Union fell abruptly, and people wanted their money back because they didn't want to spend the kind of money that they had been spending for 30 years on the military. And so they cut back on defense very heavily. There were a bunch of layoffs. And spending didn't really come back until 2011, or 2001, September 11th, 2001.
But even then, it wasn't, I don't think, funding this technology.
It wasn't
It was going
There were
towards troop
projects.
deployment.
Yeah,
And, like, munitions,
Well, there were
I'm sure.
projects like IED jammers, but those took 10 years to develop.
Well, I mean, we had to be there, and
Yeah.
you had to have roadside bombs before
You had to have IDs.
You had to, yeah. So the cat and mouse game of warfare in general
yeah.
stopped in 1991, and that's when my
Yeah.
dad founded the company.
Well, and there weren't really cell phone like this. The cell phone industry was there and it was picking up, but
Yes.
it was like sub 3 gigahertz, like 900 megahertz stuff for a very long time. It was pure RF, no microwave.
Right.
So there used to be now I think people don't recognize much of a divide between military applications of microwave and commercial radio applications. But I think at that time and for 15 years, during most of the history of Markey Microwave, this was very significant.
The first 10 years, my dad made his dinner off of microwave radios.
Yeah.
Yeah.
Microwave backhaul.
Yeah.
Like, which I think a lot of companies made their dinner off of until pretty recently.
Yes.
But that meant that most of the industry was aged significantly. There weren't a lot of people that were.
Yeah, you're talking
Within-
about demographically?
Yeah, there's like a 15-year window where no one came into microwaves.
That's right.
Between like 1990 and 2005 or whatever.
Yes.
Nobody was coming in, which means that the companies were aging and things were pretty much stagnant.
Yeah, so when I started in 2007 and I went on my first business trip, I was the youngest person in the room, typically by 25 years. It was wild. Like, it was, and I got checked. Like, these mostly guys, the gray beards, they would push me around, and I had to learn my chops very quickly about how to, contend. And frankly, it wasn't that hard. because we had been beaten up by professors for 5 years.
Yeah, you come out with the bunker mentality of a grad student.
If anything, they were hitting me as hard as they could because I was probably a cocky punk.
And the Markey kid.
Well, yeah, and that was the other thing, right? I was the son, and
Yeah.
I felt a strong conviction that I had to prove that I wasn't just the son.
Yeah.
So, anyway, yeah. So that was what was happening was that the company was formed off of the microwave radio industry. Then in the mid 2000s, and the wars were going on, you started to see a gravitation back towards what my dad was doing because he could still accomplish the highest performance in mixer technology despite the ICs. And I started then, and that's when I appreciated what he had done, really. And I got to know him on a kind of new level.
A technical level.
Yeah, a technical level. Like to say, wow, like that was some genius work that he had done.
Well, and you have to understand that your dad is, for people that don't know Ferenc Markey, he is very, very much in love with the microwave mixer. Like, he is very interested at all times, I would say, in his work.
Yes.
And so understanding, I mean...
Obsession is important if you're a designer.
Yeah, yeah. And as soon as I started here, I would come in on Saturdays. He would be coming in on Saturdays. Mm-hmm. 45 years into his career, with nothing left to prove, he came in for the love of the game.
Well, okay, yeah. So, as I've said this many times, my dad is more artist than engineer.
Yeah.
And nobody criticizes Paul McCartney for writing a song at 75 years old.
Yeah.
Not that my dad is Paul McCartney, but the part of your brain that makes you want to write songs is the same part that makes you want to make an invention.
Yeah.
There's no doubt. So my dad is an inventor for sure. So anyway, that was the state of the company, which was that we were stable enough and could probably last plus or minus 7% for most of my career. And to this day, that's been the case.
Did it ever like appeal to you, the idea of just like chilling and just like making the stuff? Like...
It never once occurred to me. Never once. Because I actually hate those kids. I hate the children of rich parents who don't do anything for themselves. Like it makes me sick to my stomach, and I was obsessed with not being that kid.
Yeah.
So it's kind of like I didn't want to be in daddy's shadow. But it was even worse. I was like hostile. I was like,
you were angry at the idea of who you as a person might be.
Yes.
If you just kicked it,
I would have hated myself. Yeah.
Yeah. Drove a nice car.
I mean, and frankly, if you're going to do that, then why take engineering as
why
a discipline?
Why spend the time doing problem sets and learning everything you need?
I would have done like what all of my friends did at Duke, which is become an economist and then go get an MBA.
Well, become a business major and then go get some beers at 3 o'clock. No offense, business majors. So you're designing couplers.
Yeah.
You write the coupler script based on a paper from 50 years ago.
Yes. Because you can't invent anything
how
new.
Did that project go?
What do you mean?
I mean, what was the end result of that project?
We can now design like any coupler we want.
But how did I think I kind of like, I know that it was successful.
Yeah.
But that was like our first coupler. That was the first Markey coupler.
Yes.
Did it ever occur to you to be intimidated by the fact that you had never sold a coupler before and you were selling it to this person that was like putting it into their system and relying on that?
No.
You're just like, it's going to work?
No. So I learned, okay, so we should talk briefly about bravery, because that's something that my dad has in spades. My dad was never afraid to release something. He was never afraid to face head on with Northrop Grumman, and there's actually a story that I hope he tells when we interview him. Yeah. But there's a story where he goes into Westinghouse, like in Baltimore, in the 90s or something like that. And it's like him in a room with like 25 Northrop Grumman engineers, possibly some Marines. I don't know what system it was on.
Yeah.
But it's like him, my mom, 25 engineers, mostly reliability and quality, I think.
Natural.
And them grilling him and him standing up for himself and just like facing down the barrage. And it's such a cool story. He'll tell it. Actually, my mom will tell it probably better than he would. But there's this. I'll let them tell a punchline for the future. But there's a kind of funny outcome from all that. But the point is that he was so brave about it, and that comes, I think, mostly up to his upbringing as an immigrant, and, always facing the odds. So he kind of taught me that in this context. Like, he always said, don't worry about it. Just do it. Release it. Put it on the website. You'll find somebody. And that coupled in with what I find to be the true value of a PhD, which is that it's the first time in your technical career where you have to do something on your own. And I got pretty brave about trying to do things on my own.
That's a really interesting idea. That
I think
that your bravery, that confidence or courage comes from the act of doing your own stuff and succeeding when you have a PhD. So for anybody that doesn't have or isn't familiar with the engineering PhD, basically the goal of the engineering PhD is to invent something that's never been invented before. Like, that's when you graduate. When you learn everything that's ever been invented and published. You invent something new. You invent maybe one or two things, new techniques that make some marginal improvement. You publish them, and then you're done. Mm-hmm. And the act of publishing is in some ways a brave act.
Oh God, that's the most nervous thing. Do you remember editing your first paper that you submitted?
Yeah.
It took me like 5 days. It was finished, and I was just working on figures, changing fonts and all that.
I was worried about claims that I was making. I was worried about errors that I had in my figures. Mm-hmm. Maybe this was probably all unfounded because no one has the time to really analyze any of this stuff.
Yeah.
But there are these curmudgeon professors that somebody's always going to troll your paper and be like, oh, figure 4, you got this line going wrong at DC. It's supposed to go to 0, and instead it goes to -1. Somebody will always find some error.
Return loss is not negative.
Yeah. They'll argue definitions and all sorts of stupid stuff. But that's a great point about bravery. I think there's the super famous saying about business that it's the balance of greed and fear, which is probably the truest statement I've ever heard about business, and probably another reason that an MBA is not a good use of 2 years is that you don't take any risks in MBA school, and business is all about taking risks and getting rewarded.
Especially in entrepreneurship.
And getting burned.
Especially when you're trying to do something new.
Yeah.
It's different if you go into work for a big company, then politics and things like that probably matter. Some of those hard skills matter, maybe a little bit more. When you're kind of on your own, and so this was the thing. My dad was on his own, and he taught me how to live in the wilderness on my own, and
hand to mouth.
Yeah, go catch the deer and skin it and prepare the meat. That's how my dad lived, and I watched him do it, and so I did it. So it was not a thing when I was making couplers. I was like, oh yeah, and this is how you gut the deer.
Yeah. This was in the era of sell the prototype. If Marky Microwave
Love that.
made one product,
instant profit,
we would drop ship it and book the revenue.
That's right. and then they asked for 5 more, and you say, "Can you ship the first one back, please?"
Yeah. We need to take some photos. Yeah, for our customers now, we are long past those days. ISO 9001 2015.
We're a much more boring company.
Yeah, we have gotten way lamer than the Wild West days of where you kill a boar and eat it the first day.
Those were the days, man.
Yeah, that was awesome.
That was fun. So anyway, we got there. Okay, so fast forward. By that point, we had established a beachhead on our passive product line, which is now today the biggest product line in Markey. If you add up all of our mixer lines, it's not as big as our passive lines, which is surprising to most people.
Well, we have more passive lines. We got power dividers, couplers, balance.
You have more. You do have
quad
more
hybrids.
But I mean,
ISDs.
for a company that's connotated with
famous
with
for
mixers,
mixers.
It's what we do.
Yeah.
It's not the biggest money generator.
Yeah.
So anyway, once I got that established, I felt a lot more confident about spending our money because I wasn't just wasting Dad's money, and that's when I started thinking about mixers and the future of mixers.
So you started in 2007?
2000. I started here 2007 September.
And you took the first crack at making a mixer, which would be the first product that was disruptive rather than expansive to our existing products in what, at what time?
I don't actually know the exact date.
Like 2012 was maybe the beginning of the development?
No, because, well, it begins with the Microlithic Mixer.
Right. And I remember you talking about that at, I think, the first or the second IMS that I went to.
Yeah, so that must have been like
our Diode
2010,
vendor.
maybe.
Yeah.
Maybe 2010. So I had begun thinking about mixers within a few years of starting.
Yeah. 2011.
Okay. Yeah, so that makes some sense. And that's around when the patent, I think, was filed.
The patent, I think, was another year after. I think you demonstrated that it worked first before patenting it.
Okay.
Yeah.
Well, it all happens concurrently, right?
Right.
So
So what is the microlithic mixer?
okay, so the microlithic... why did we come up with it? Maybe is the first question.
Why is
Okay.
the microlithic mixer?
Okay, so the here was the calculus. I had recognized that we had a diode supply that was pretty much 98% coming from metallics. And I had recognized that the packaging of those diodes into bigger packages in the form of conventional hybrid mixers was nerfing performance. Okay. So I was like, well, can't we somehow attach the diodes more directly to the substrates?
Yeah.
And
this is a subtle technology point that I want to elaborate on a little bit more because it's very, very esoteric and confusing for somebody that comes from outside of the hybrid mixer, like hybrid assembly area. But the way that you make a diode, the way that Metallics made their diodes.
we need to get JC on it.
Yeah, JC's a good interview.
Yeah,
he's a good guy. So they would make one type of diode that's a beam lead diode, where they would fabricate the diode, like the junction, plate gold on top of it, and then etch underneath the gold,
like etch like the body of the
to
wafer.
lift off.
Yeah,
this is for somebody with a fabrication background, I was like, what? You're lifting off the metal and then you're balancing this delicate. Like I would never believe that it was something that was done if it didn't already exist. If somebody came to me and was like, "This is what we're going to do,"
it's
I'd be
insane.
like,
"It's insane." It's like
idiotic.
It's like captured in like a glass that they like somehow
they pass it
fire or something.
Very complex process. And then there's another process for making hybrid mixer diodes where you take a diced diode and you wire bond it into a lead frame.
Yeah, which is like everybody else.
Yeah, which has leads.
That's the only way to...
That's the only thing that anybody besides Metallics did.
Yeah, almost nobody does beam leads anymore.
For reasons that they are insane. Right?
Well, yeah, there's a reason you can't really buy them anymore.
Yeah. There's a reason that no one is rushing in to copy this technology.
Yeah.
Okay, so your idea was that instead of taking a beam lead diode and bonding it into a ceramic package with leads and then soldering that ceramic package into a hybrid mixer, you were like, what if we planarize the circuitry and put it into the ceramic package that we bonded on originally?
Correct. So you have to remember something. It's an important thing because like to an IC designer listening to this, they're going to be like, you guys are idiots. You could do all of this in an IC. Why aren't you just doing it that way?
Yeah, why muck around?
And there's
with it?
a very simple reason, sir. Money. I did not have $500,000 to burn to run a bunch of experiments to see if I could do it in the first place. Because there were no training wheels. I had nobody to talk to. Nobody in the company knew how to do ICs.
I think a bigger barrier than maybe it appears to be at first is that there is black magic in ICs. Right. Now I think now there are a lot of people coming out of grad school that have experience having designed MMICs in their PhDs or masters. I mean, I think they teach it in undergrad now for some classes, but this was not. It was my impression that it wasn't common 10 years ago.
It really just came down to risk reward.
Yeah.
It wasn't clear that we could succeed within a few tape outs to make something of value because, and this is the other, hubris will blind you to the facts. I was under the strict belief that you could not make good MMIC mixers.
Yeah.
Because, and here was the assumption, if you could, why wouldn't people copy my dad and his circuit designs and just do them on a gallium arsenide substrate and beat my dad at his own game because he was still selling mixers.
Yeah.
And so my assumption was it must not be possible because surely they're smart enough over at Hittite to copy what my dad did. And to this day, maybe we'll talk to somebody from like those days, like the 1990s Hittite mixer designers. Why they didn't do that makes no sense to me because they could have, and they could have gotten the performance we're seeing today in our stuff.
I think that there's something huge that you're taking for granted, which is that
30 years of hybrid mixer design.
Well, how many hours of conversations did you have with your dad about balance design?
So even though I didn't have an integrated circuit help, I had help on the, I guess call it the mixer philosophy.
I remember the first several years that I was here seeing the way that your dad would draw a mixer. Mm-hmm. He'd always use two or three colors of ink so that he could draw the different signal paths. Yes. And he would like just kind of loop them together to indicate a balance. And he'd show the balance. And I tried one time to make a video, I think, explanation of a mixer the way that your dad does the mixer explanation because it's so beautiful. And I couldn't do it. I messed it up. Right. I got up and I drew the diode ring and then I started like putting in the balance and stuff. And it kind of fell apart. I had to go back to my notes.
Well, this comes down to like a basic thing. You use the resources you have and mitigate the risks or the downside risk of the things you aren't good at. So that's what I did. So what happens is I didn't have a ton of money to waste building mimics that may not work, especially because I assumed that mimics could not be done better than what we did today. So I wasn't willing to make something that sucked. But we did discover that it was possible to make ceramic circuits that had multi-layer capabilities. And that's what eventually became the Microlithic Mixer, which is patented. You can read about what we did. But basically, it's a multi-layer, like multi-level metal stack up that allows you to realize what I would call like semi-complicated balance structures in a platform that can directly accept beam lead diodes, or actually any kind of diode. It could be flip chip, it could be bonded, it doesn't really matter. It can accept a direct die attach of a semiconductor. And it can do that. And the key was that it could be multi-layer so that you could realize the complicated balance, like the broadside coupled balance that my dad was always using. So what I tried to do is I just tried to make exactly what he had done for his entire career on ceramic. And that worked out. And it turned out that nobody had really done that. Other people had tried like LTCC and things like other types of approaches. But this one worked really, really well.
Why do you think that no one had tried that approach, the ceramic multi-layer approach?
Well, I'm not actually sure when it would have even been commercially viable from the suppliers. When I saw it, so when I saw it originally, and we were talking to the original supplier, I was blown away. I didn't even know it existed.
Well, I mean, I think we found that it's not necessarily
it's not easy.
Still commercially viable.
It's on the edge of
hard to maintain.
Not just anybody can do it. It takes like
there's not a huge market for it the way there is for like mimics are hard to maintain, but there's cell phones, right? They will always be able to make for the rest of our career mimics.
Yeah. So what happened? So the reason that Microlithic was important to the company was that it, even though it wasn't a full IC, it was IC-like in its repeatability, and it could. The other thing was it could utilize the same diodes we had already been buying, and that was critical because one of the things that we always would hang our hat on was the fact that we would make mixers with silicon diodes. Yeah. Silicon diodes have certain features like lower phase noise, and you can buy them with low forward voltage. Right. That did not exist in any way in gallium arsenide at the time. Right. You couldn't just go to a gallium arsenide foundry and say, I want the low voltage diode. They didn't really sell it. And so we would sell a lot of mixers that were +7 to +10 dBm drive.
That was the standard.
And that was the standard that we would sell versus a MMIC design, which was going to be 13 plus dBm. And that was the differentiator. And we said, okay, let's make a Microlithic product line and go with that. So that's what I did for a couple years.
Well, I think there's an interesting thing here where why do you think that people still bought the legacy mixers in 2012? How much of it do you think is legacy, like design ins, and how much do you think was new design work?
The majority of it was legacy, and new designs were T3s.
So that follows the trend that I think we perceived then and continues now, which is that for most of the history of microwaves and radar, noise figure was very, very important. Low loss, low noise components were important because it was a relatively quiet environment and power was expensive and gain was expensive. Right. And with the advent of particularly MMIC amplifiers, gain got cheap, power got cheap, the signal field got loud, and
modulation formats got complicated.
Modulations got complicated, and more the peak to average power ratios went,
and the environment got very crowded.
Yeah.
With jammers.
So the important factors now for a high dynamic range system aren't low conversion loss, which is a specialty that we still cannot defeat in hybrid mixers. Like,
so last week, did you see that mixer? We had a 3.2 dB conversion loss or something like that. It was crazy. But we can still do things that are, I would say, virtual impossibilities outside of the hybrid domain.
Oh, it was a hybrid mixer.
It was a hybrid mixer. Yeah. You cannot do it.
Yeah, we can't. The metal lines are like no chance.
Yeah.
So that was like the critical feature: high isolation, low conversion loss, low LO drive. LO drive was expensive. Now,
Yeah.
LO drive a lot cheaper.
That's actually, I think that might be one of the biggest reasons.
Yeah.
Is that back in the day, like if you wanted a 2 to 20 gigahertz, 15 dBm or higher output, that's $100 chip.
Yeah. Now it's a commodity.
It's becoming a commodity. Yeah.
Yeah. Now the high performance chips are 30 dBm, 40 dBm. Like who knows where they're going to end up?
Right.
With GaN.
Right.
So that gets us through microlithics. What was the experience like of designing microlithics, and what did you learn from it?
Okay, so that's a great question. So it was a stepping stone that became profitable within about 12 months. So it sort of satisfied the need to not make too big of bets. And still push the technology further. So the first thing we noticed, and the first thing we would market to the customers is, it's the same performance but smaller. And it was like 16 times smaller than the nearest competitive Markey product.
Yeah, I remember that.
And that was a big deal. Like that was no joke. Like, because neither my dad nor I knew if it would work, but it did. It worked fine.
Well, and that was the big push. Like originally, that was the requirement, is that it was small, and we couldn't compete with small.
That's right.
Surface mount or chip mixers.
Yeah, so sometime around 2009, I remember going on a business trip to the East Coast and talking with a bunch of customers, and they'd say, and I talked to them about what they were using, and it was pretty much always some kind of HMC part. Yeah. And I'd say, oh, is it because of cost? And they're like, not really. Yeah. Which was a surprise to me, because people would always, back when I started, people would always bash Marki, oh, they're too expensive.
Yeah. Well, in grad school, and as a consumer, I think, you learn that cost is everything, volume's everything.
Well, you have no money in grad school, so cost is everything.
Yeah.
Right. So you get into this like technology field, and you're talking to people who are like, no, performance, I don't really care what it, like if it's
I'm putting it on a $100 million jet.
Right. Yeah. So if it's $30 or $90, I don't really care.
Yeah.
But they would tell me, I can't fit it on my board, Chris. So if you can make this thing smaller, I'll buy yours. I don't care. I have no affiliation, or I have no affinity for the other guy's MMIC. It's just yours don't fit.
Yeah.
Too tall, too big, whatever. So that was it. It was like, okay, let's make it like an order of magnitude smaller. Check. Did that. It got designed in, and it did very well. So the question is, why did we go beyond that? And it really comes down to diode.
Yeah.
And it's not just the fact that diodes are expensive and hard to source, and we were sole sourced mostly. Like there weren't really a lot of options.
Yeah,
for
90% sole
yeah,
sourced.
it was pretty much sole sourced by Metallics, and so I would get calls. Well, so once we started coming out with the microlithic products, and we were going up to about 50 gigahertz, we got a lot more calls than before about, you know, what's the next thing you could do? Like, can you do this? And the big thing was, can you make it more linear? Everything was high linearity at millimeter wave.
Yeah.
This is 7 years ago, probably. And I would talk to the guys, and I'd say, well, let me talk to Metallics. Because it was being driven mostly by the diode.
It's diode.
There wasn't more I could do on the mixer side.
Yeah. And you had essentially no control over it. Like the control you had over the diode was making a phone call and saying, can you do this diode? And then somebody would run an experiment and get back to you. And then whether you could actually get that diode in volume for years.
I could get it once.
Yeah.
Whether I could get it in the future was like a completely different question. Yeah. The thing about beam leads that people need to understand is that they're very boutique-y. So like you can get a magic wafer, or you can get like a magic portion of a wafer, but you might not get the whole wafer to look good for what you need. And so I was chasing my tail a lot trying to support the production, because it was like, well, this is like 30% off on the capacitance. The whole band shifted. And it was just so frustrating, because you had a great thing that people liked, but you couldn't support it to the way you'd like to. It was just a stack up of fab tolerances that started killing me. And that's when we started talking to customers about, you know, they would say, well, what would it take for you to do better? And I'd say, I need better diode technology. And that's where we started looking at MMICs. Thank you for listening to episode 1 of the Marky Microwave podcast. Be sure to catch our next episode, where Chris and Doug tell the rest of the story behind how we transformed from being a small, hand-built mixer manufacturer into a cutting-edge semiconductor IC company.